All right. Welcome, everyone. Happy to see so many interested in security. I recognize some of the faces here from our security day this week on Tuesday here at Øredev. So you guys will probably recognize some of the stuff you see here from the security day. But it's probably good to hear it one more time to make sure you got everything and you get more opportunity to ask some questions here once again. And again, happy to be here. Hope we don't feel like we're on the top of K2 mountain by the end of the session. Think the air might get a bit thin by end of our presentation. But my name is Emil Kvarnhammar. This is Sebastian Olsson, my colleague. We're both from Truesec, and we're going to talk about security for developers. And talking about security in development, and of course we could probably stand here for a full day talking just about security, but to squeeze something like this into a 40-minute session, we decided to iterate through a development lifecycle and talking about each step and what we need to think about in terms of security. Of course, we can't cover everything, but we'll talk about some of it, and we'll hope that you at least get a glimpse on what's important. And for each of the steps, we'll talk about some common mistakes and some stuff you can do to improve the security in your development teams. So to start with, when we start a project and with preparing and designing, of course design is a lot of stuff to cover, but at least in the preparations, make sure you have some security implemented on your development computers. And that, of course, also includes build service, and we also need to make sure that we have good control over the security or the who has access to the source code repositories. So about development computers, one thing that's extremely easy to implement, and unfortunately very few do, is encrypting your hard drive. I mean, if you have a laptop, if you're running Linux, OS X, or Windows, all of them have encryption implemented in the operating system. It's extremely easy to enable. So there is no good reason. It's very low performance penalty to do so. There's really no good reason why you shouldn't. If you don't have, for instance on a Mac, if you don't have enabled file vault, then you have an open door to root access on your development machines. It's just by booting the machine into recovery mode or single user mode. The same goes for Linux, similar in Windows, but with some different tools. So please use encrypted drives. It's an easy one. On build servers, and especially with regards to access to source code, another common mistake is that you grant access to the build server account, and you also thereby you also grant access to push updates to the repo. Unfortunately, that also means if the build server gets compromised, not only will the attacker get hold of your source code, they will also be able to update your repo, and you might not detect such updates, especially if you're in a complex project. And in addition to that, there's of course a lot of stuff to consider, like surfing. Don't use your administrator account on your machines, but I bet you already know about that. You probably heard about like vulnerabilities that could mean that attackers get control over your system and things like that. So going on to the development, the fun part, right? One thing to note, code reviews save lives. I mean, I'm pretty sure that some of you do code review as part of your development. But if you don't, then if there was to be some kind of security review of your source code, I'm pretty sure that the reviewers would find some security vulnerabilities, because it's so easy that some kind of vulnerability or flaw is implemented accidentally. Because there's a lot of stress. I'm not saying that people are not thinking about security at all, but maybe it's not prioritized at the moment. But if you have code reviews as part of your development process, then it's a natural part that another developer in the team questions, well, do you actually handle input validation enough in this piece of code? So that's really important.
And it also helps a lot to spread the knowledge of the code base to the entire community of developers in your project, so that everyone knows how the whole application works. So we cannot stress this enough. Just mandated code reviews are really, really great. It's like we said earlier, it's like pair programming, except it works.
Yeah, that's a good point. And I think probably many of you use HTTPS, or hopefully not, but maybe HTTP in some of your projects, either between the client and the server, or between servers and servers and things like that. And one thing to note, always use TLS. It's the same or similar as with encrypting your hard drive. It's something you get almost for free. There's very low performance penalty in doing so, unless it's an extreme system or with too many users. And of course, then if you have so many users, then you probably have a lot of money to buy hardware. So again, there is no reason to not use TLS. So because a common mistake is that people don't secure the traffic at all. And by sending everything through just HTTP, then everything is, of course, in plain text. That doesn't only mean that people can eavesdrop on the traffic, it also means that people can modify the traffic. And modifying the traffic could lead to code getting crashed or code getting to execute on the target system. These things happen. And especially, well, of course, it depends on what kind of system it is. But we're going to show you later what sending data over or sending code over over an insecure channel could mean. Similar to this is when you secure only parts of the traffic. Consider, for instance, if you're implementing authentication using OAuth 2. Then it's extremely important that you use HTTPS. Because if you don't, then there is really no security in OAuth. And that, in general, that usually means you have some kind of logged in zone and you have an insecure zone. And if you use the insecure zone as an entry point over HTTP and then go over to HTTPS, then that opens up for man-in-the-middle attacks. And man-in-the-middle could easily just strip all the SSL parts or strip the HTTPS URLs and replace them with HTTP URLs. That's an easy thing to do. It's nothing complicated. There are already easy tools to use. Similar to that is if you offer some kind of fallback. And that doesn't only mean fallback from HTTPS to HTTP, it also means within HTTPS. Depending on what your server configuration is or your client configuration is, there might be a scenario where it could fall back to using weaker cipher suites or weaker versions of SSL or TLS. For instance, there have been attacks proven in the Poodle attack that's been published just a couple of weeks ago, where you downgrade the communication to SSL version 3. And by doing so, you could extract secret data. So, and also if you have a fallback in general just from HTTPS to HTTP, then it's just for the attacker to block out all the traffic going to port 443, for instance. And that would make all the clients go to HTTP port 80 instead. So again, always, and I mean this, always use TLS. If you have a good reason or would like to explain a good reason, we could definitely have a discussion afterwards. And we're open for that kind of discussion. But so far, we haven't seen any good scenarios where you shouldn't use TLS. So what does this mean in general? Does anybody know what SSL, well, I'm sure everyone knows. What's the first thing you think of when you hear SSL or TLS? Certificates, something else. So that's a good point. That's the first time we have that. Something else.
What's the purpose?
Oh, encryption, that's right. That's usually the first part. You got us there. That's, oh. Oh, you're cheating. You were here this Tuesday. Yeah. That's the other part.
Yeah, that's not cheating, though.
Maybe it's not cheating. It's, yeah, it's being a good developer. So the other two parts, what we're trying to stress here is the other two parts are actually even more important than encryption. Encryption is confidentiality. And if you only have confidentiality, then you don't know whom you're talking to. Imagine what that means. If you're communicating with an internet bank, for instance, what's the most important? If you're transferring 1,000 euros to your friend, is it the fact that you would be able to hide whom you're transferring to or what amount you're transferring? Or is it to make sure that you're actually talking to the bank and not somebody else intercepting that and modifying the target account and the amount? It's pretty certain that authenticity is important. And that's what we do through certificates. We need to make sure that service certificates are validated. The service certificate is one of the first parts that the server is sending when a handshake is started. And that has to be validated towards the trusted certificate authorities in the system. This is something that you usually don't need to worry about. But it might also be that you're trusting too much. Maybe you don't need to trust like 200 certificate authorities. If your application is only talking with one server and always that server, maybe you only need to trust that server and not even the issuer of that certificate. So think about that. That's something that's called certificate pinning. We're not going to go into certificate pinning, but if you have a scenario like that, look up the details on how to implement certificate pinning. So again, if we don't do certificate validation correctly, then we open up for man-in-the-middle attacks. This is equal to sending traffic in clear text. And this is something that people not always know about. People tend to think that, well, it's encrypted, so no one can read it or modify it. But they definitely can if the service certificate is not validated. Because if it's not, then a man-in-the-middle could just auto-generate a service certificate.
It's really simple to do these types of attacks.
Yeah, there's tools like MITM proxy, burpsuit, yeah, a lot of tools that is really click and play for man-in-the-middle with new certificates. So actually, this is more like sorry, this is more like grandpa in the middle, because it's just as easy.
It doesn't have to be the hooded.
We got some criticism earlier this week from Joshua Corman that we're using the hoodie too much, and no security guys wear hoodie, he said. Well, I actually do sometimes. But just to illustrate, this is extremely simple. This is not hardcore. So it's not even at a script kiddie level. And if you have code, God help, if you have code looking like something like this, then you might be in big trouble. when you just bypass certificate validation. This is a Java example. There are similar examples from C#, whatever. And this means that you circumvent the whole purpose. You circumvent the authenticity checks in SSL and TLS. This is something that people sometimes do just to be able to communicate both with the test environment and with a production environment. And the test environment has some, I see some people nodding here. I don't know. I don't know if this is the reason, but. So definitely don't try this at home.
No.
Yeah, you don't try it at work. You could try, don't even try it at home. I mean, the code you're developing at home could possibly end up in a kick-ass product. So don't try it at home either.
Yeah, there's really no reason to do this kind of stuff, because why are you spending time implementing TLS in the first place if you're just going to disable it?
And talking about certificate, excuse me?
Because you told us to, every time, always use TLS.
Yeah,
yes.
But then you should also implement TLS, not bypass it. So there are much better solutions than doing this stuff. And we see this stuff, like Google this and look up the Stack Overflow answers with the green thing and like 150 upvotes. Oh, thank you so much. This really solved my problem. No, it really didn't. You just gave you a bigger problem. So be careful about these Stack Overflow type comments and solutions to problems like this. Be critical.
But I mean, if you do a correct implementation of this, you might actually end up with a correct certificate pinning implementation where you only trust your own server certificate. So it's not something wrong in general to implement the trust manager, but you must know what you're doing.
Yeah.
Speaking about certificates, I'm gonna hand over to Sebastian to talk about trust.
Yeah. I'm going to talk a bit about code and trust in code. So this is a concept that you need to think about all the time when you're developing something, because you often have interfaces somewhere that takes data in, and you can't trust data that comes from the outside. You need to establish some sort of trust boundary where you know that you can trust the data in some sense, that you know it's data that matches your domain somehow. So you need to make trust a first-class concept at trust boundaries. Now, what does that mean? Well, let's say we have your application, we have your domain logic with all your magic sauce in it, and then outside we have all these scary web service interface, database connections, and what have you. And then you have the trust boundary. And when something enters the trust boundary, it must be validated. You must be certain that it is in some sense valid. And for example, one thing that people don't think about, we have the database over there. That's outside your trust boundary, even if it's in your data center. You should still validate data that you're reading from somewhere outside. You can't just trust it because it's in your system. And we'll get to how you solve that. But I mean, the normal thing is, for example, if we have a string, that's an account number, and then we have an integer, that's an amount. So this is a transfer I'm doing at my online bank. What you would need to do is you would need to have a validation step to make sure that this integer and this string matches what is reasonable for an account number and an amount. For example, an amount to transfer cannot be minus 100 euros. I cannot give myself money from someone else's account by doing a transfer of minus 100 euros. These types of things have happened in web shops and stuff like that, when people actually got money back by adding -2 of something they wanted to buy. So you need to check this stuff at your trust boundary. This is hard to do, of course. How do you find all the places that you need to do this? And the thing is, you need to have a structured domain where you can work with these trusted objects. And there's a very nice concept that you should think about that's called domain-driven security. The concept in itself is pretty easy. The name was coined by a Swedish developer at Omega Point a couple of years ago. The thing about the idea behind domain-driven security is that you leverage the power of your domain objects, if you have a statically typed language or a strongly typed language. So you really use the power of the type system and your domain objects to make sure that the validation always occurs. Because, of course, everything within your application, within your domain, Of course, it only works with domain objects. It doesn't know about a string or an integer or something like that. It should know about an account number or an amount. An account number has some sort of validation in it, and an amount has some sort of validation in it. So in order to pass an amount or an account into your service where you handle this, it needs to be created as an account and an amount, and in order to be created, it has to be validated because you have the validation in the constructor of the object, and thus you cannot miss a validation with domain-driven security if you have a somewhat strongly type language. So even if I load it from my database, I still have to construct it as a domain object, and therefore I always get an exception if that value is not correct. If someone has injected some sort of reflected XSS into the field in the database, well, then a script tag does not match an account number, so that will not work. So it just adds a better trust and a better security throughout your system. So here's an example of an account number that's actually, I don't know if it's easy to read, but in this case it's a digit between 10 and 12 numbers. And in the constructor, I always check if it's valid, and it's only considered valid in this case. It's a simple example. It's considered valid if it's not null, and it also matches this pattern. Otherwise, I throw an illegal argument exception. This is the Java code in this case. I also added the static constructor method there because I think that's nice. And I made sure that everything is final here. I will get to that very soon. But in this case, you cannot create an account number without making sure that it is valid. And also, as an added bonus, something you should do is have the null checks in these domain objects, so you know also that these objects are never null, so you don't have to do those checks everywhere. Because instead of null, you of course use optional or something like that. And then we go to the second thing I want to talk about that is actually directly related to this, and that's immutability. You know, most of you probably know what immutability is, if not all. But immutability means that the things cannot change suddenly. If you get an account number into a method, you don't want account number to change on row 3 when you validate it on row 1. For example, we have the talk_to, time of check, time of use. If I check that bar is valid in the beginning of the method, it cannot be acceptable that there is some other thread that comes in, modifies the value of bar after the validation, so that I use it within my domain without validation. And with immutability, such as in this case, the account number can never change. I know that it's this account number. The value within can never change. It's immutable. And your objects should always be immutable, unless you have a really good reason not to, because immutability really makes it easier to have good security and a good architecture. It's like Andreas said, it's like a magic security spray for your application. It makes everything nicer and better. And it also reduces bugs and makes it easier to do functional stuff if you're into that kind of thing as well. We talked a bit about web services. We have a couple of common mistakes in web services. Typical one would be referencing objects directly. Just having a URI where I can just reference some object with an ID, and I can change the ID field to something else and try to just force myself into this interface. Another common one would be having entity CRUD operations, create, read, update, delete operations for all of these objects, just for the sake of it. I mean, having an HTTP verb to do something is not a good reason to expose that to the whole world. Simple human-readable protocol formats and transparent friendly names. Developers love this and testers love this, but attackers love these as well, just as much, if not more. So if there's no reason why you should tell the whole world exactly the inner workings of your application, then you shouldn't, because not every application is an open API. Not at least not outside of San Francisco. So we could probably find an acronym for this, but I'm not going to say that REST is a problem. It's not. It's just that a lot of these frameworks for REST and a lot of the IDs really make it simple to mess mess things up when it comes to security. So having a nice REST framework exposing your object is not the solution. You still have to have a validation for each of these calls, and you need to make sure that all the calls are valid within your domain. Now, I mean, the simple human readable thing, that could seem like security through obscurity, and in some sense it is. But that's a common mistake to think that security through obscurity is a bad thing. It's not. It's only a bad thing if it's your only security. Then it's horrible. But otherwise, it still adds security. But you should have to find something, some good ground there. So take this example. I'm user 1, 2, 3, 4, 5, and this is my user info page I'm getting when I'm logged into your service. Now the first thing I'm going to think, why do I see this 1, 2, 3, 4, 5? What's the reason behind me seeing this ID, this database ID? I have no idea. I'm gonna try to check 1, 2, 3, 4, 5, 4 or something else to try to find out if I can get other users' data. Now, why would you expose this interface to me? I'm not allowed to modify this idea. So why am I presented with it? There's no good reason at all.
We see this all the time.
All the time.
Happens everywhere in all web services, especially web services that hands data to some application.
Yeah, especially in critical, big, known web services. So, I mean, something that people would do would be something like this, perhaps. Oh, we use a UID. It's random and it scales better and everything. Yeah, that's nice. You should probably use UIDs internally. But that's not a solution to this problem at all. Because I should still not be able to modify. I should not have this degree of freedom to modify it because I can find someone else's UID somewhere. That's just, that would be relying only on obscurity. So a more reasonable interface would be, for example, user info current or just user info, where my actual authenticated session would provide the ID internally. I don't expose the ID and I don't make it possible for me as an attacker to try some other ID. This is very, very common, and it's just a special case that we wanted to bring up, because I bet most people have made an interface such as this, where you have a parameter that should really not be a parameter. So, moving on.
All right, so moving on to the build step. And a core part of security in builds is to know where your dependencies come from. And we mean really, where do they come from? Not what project they come from. Where do they originate? And are we sure they are not being modified on the way? So looking at, I think Joshua Corman mentioned a good example that about 90% of the source code we use is from third-party sources or from open source. So looking at the Maven dependency tree, if you're using Maven, then you're probably quite familiar with this. And this is from a simple Java Enterprise example. The situation is usually a lot worse, but this still shows that there are quite many dependencies just in a simple project. And we not only we need to look at what packages we're using, we also need to worry about what versions we're using. We're going to see a simple example where things go really wrong.
And you really need to, just to add something, you really need to have like a structured way of documenting and finding out which exact versions you're using. Because how else do you look for known vulnerabilities in those third-party libraries? Do you even look at regularly for known vulnerabilities in those projects? Probably not. But that's the first thing we'll look at when we get to an application. That's like the low-hanging fruit, just using the normal, very well-known vulnerabilities that's been there for years, but you're still using that version. You need to check for vulnerabilities. If 90% of your code is from a third party, then you need to check for vulnerabilities there.
Yeah. So looking at a typical build scenario where you're using Maven, for instance, it doesn't have to be Maven, it's just in this example. So on a build server or a development machine, we do some kind of build, we get dependencies over the internet, and these are actually quite often retrieved using HTTP. Imagine what that means. So stuff that you download from the internet ends up running on your client computers or client devices or on some kind of application server. So again, we removed the hoodie from this picture too. So this is Malcolm in the middle instead. And the same goes for this download. This can be intercepted. We're going to show this quite in a while. This can be intercepted so that evil stuff ends up in the downloaded package. And evil stuff ends up running on the development machine or the build server. Think about the credentials again, like code signing credentials and things like that. And the evil stuff ends up in our target environment. We're going to show you how simple this is. Cross-build injection.
Yeah. So most Maven projects would be vulnerable to this stuff. Actually, just recently, newer versions of Maven download from Central over HTTPS, but that's like from this summer. Earlier, you had to pay $10 or get the Nexus Professional to be able to download it securely. And you should download securely, but you should also, if possible, check signatures of those downloads. Maven Central, for example, often have PGP signatures that you can check. Let's see here. So I got my victim here is a developer, and on the same network I've got an attacker. The attacker has done some, well, Malcolm in the middle attack in this case, running an evil web proxy. He's also running a reverse shell server, which is something I'll get to soon, listening on the port. And I've got this project. So I'm going to prepare my project. I got the vulnerable class, low resolution. The vulnerable project has a POM file for Maven and also a Java file. So looking into the POM file, it has a dependency on Google Guava, which is a utility library that a lot of people use. And it also has a vulnerable class. It's not vulnerable yet, but I mean, it uses the tree multimap, imports it, and creates a tree multimap for no good reason. And then for equally bad reasons, it just creates an object and synchronizes on it, so it won't quit in this case. So nothing really evil there. Let's go into the vulnerable project and build. Maven clean install. Let's see what happens. So I'm downloading Google Guava from repo.maven.apache.org. It all seems good. I'm getting the Guava jar right there, compiling, and we're good. Build success. Now looking into my attacker computer, I actually got a lot of calls for some POM files, what have you. And here we have the request for the jar file. I'm doing some evil modification and injecting references in a bunch of classes here that I found. And then I'm adding my own class, reverse shell.class. And also, since Maven checks a SHA-1 checksum for all the files it downloads, you might think you're safe, but I mean, a checksum is not a signature. So the only thing I do is I recalculate the SHA-1 checksum for my new library. And when they request the SHA-1 checksum, I send the modified one. So if I go into my classes directory, I've got my class here, and I'm gonna just copy, because I need to add my class path to the Maven class path. I add Google Guava to my class part, and then I start, and I get it connected to attacker, connected. That was not in the source code. I bet it's not in Google Guava normally either. So I got my reverse shell server, so the client has connected to my server, and I can do some fun stuff. I can print the working directory on that client. I can execute random code as I feel like. In this case, that was not pure commands. I actually injected bean shell, so I'm running in the virtual machine, and I can extract memory and run Java as I please within that virtual machine. So as an example, I can run some swing stuff here. A J-up champagne. Let's see. That works. Yeah, so I got and this was not part of my original application. I don't know if you noticed that. So it's pretty sinister, and the easy solution is that you need to check how you validate downloaded packages and make sure that you have a secure connection. If you're using Maven, make sure you're at least using TLS, and don't just randomly add repositories because they have some specific project you need to. Because if I was an attacker, I would position myself within a consultant firm, and just in that case, I get my evil code on all the applications you deliver. All right. Let's see, I'm actually going to continue. Yeah, you also need to think about who should be able to sign your code. Probably only someone who's responsible and can take care of signing keys. No one else should be able to sign your code. Normal developers should not be able to sign code, and you should not sign code on your developer machines. Neither should you have your signing keys in a source code repository or something like that. That is really, really simple to do better. Please don't do this. Do not spread your signing keys everywhere, because they're your identity. You don't want to lose your signing key. You don't want to end up like doing something like some large music service from Sweden did, where they had to ask all their Android developers to download another application with another name and another package for no good reason. No one knows why. Could be that they probably lost their signing keys. And coming into this, I bet people will be affected by this one. Do not sign in your build server. Never, ever. That is equal to this. That is just putting the key under the doormat or on the tire. There is no reason to sign in your build server. You must have a structured signing ceremony where someone responsible takes the signing key and signs the project. Because what you're doing if you're signing on your build server is you're turning your build server into a signing oracle. So anyone who can push can get it to sign anything in your name. And Jenkins cannot be the identity of your corporation. So please don't do this. And just quickly about testing, because we got to quickly just test all the degrees of freedom, which saw the insecure direct object reference earlier. You need to test all those degrees of freedom. But then you're going to tell me, well, Sebastian, we have so many degrees of freedom. Well, don't have so many degrees of freedom. Try to remove most of them. You don't need to support all those protocols. You don't need to have all those parameters exposed. If you just slim it all down as much as you can, just try to make it smaller and leaner. That's popular, I guess. Because it's easier to test all degrees of freedom if you have fewer degrees of freedom.
All right. So the final part, looking at the code we run. Do we know what we're running, what code we're running? And this is more complex than you can think of initially. It doesn't only involve the dependencies. We're going to see a demo in a short while as a final part of our session. But it's important. This is related to the build discussion, right? We need to make sure we run the same dependencies, of course. And we need to make sure that there is no injections going on when downloading those dependencies in the production environment, of course. Also, insecure configuration at runtime could lead to serious vulnerabilities. Like if you have the ability to communicate using SSL version 3, then that opens up for the poodle attack.
Yeah, so just assume that, try to have as small an interface as possible, like in the TLS case.
The stuff you don't use, remove it.
Yeah.
And so, about the last demo, we're going to talk a little bit about running web applications or hybrid applications in a mobile device. There is a vulnerability for the Android web view. It actually affects the Android browser, which is implemented based on the web view, up to version 4.1.2. And it also affects so-called hybrid applications or HTML5 JavaScript-based advertisements. If they're embedded in your application, that might open up for attacks like this. And the situation is a lot worse for those, because then it's the target SDK version that is going to tell if you're vulnerable or not. It's not the Android OS version. So looking at how this is used, you have your web view, you call add JavaScript interface, you send in a Java object, and using a textual reference or a name for that object, you can then refer to that object using JavaScript. And if you have a method called myAppMethod, then you can call that method, of course. But what they didn't think of is you can also call all the other methods that are inherited from Java Lang object, for instance. So you could call getClass loader. You could load any class, like runtime. Runtime, get runtime, exec, to execute any command on the system. So do we know what code we're running? We're going to see this in a demo. That's the...
Yes, and it's important to note the fact that you can mitigate this by setting your target SDK platform in this case.
Yeah, definitely. I forgot to mention that. I'm completely lost.
Yeah.
There I am. So I'm going to just start Netcat. This is just a simple TCP listener. And this is to have something acting as the reverse shell server. And I can't show this to everyone, but I'm going to show it to the people in the front row.
Should have had a document camera here, but...
Yeah, but it doesn't matter. This is not the important part, except that the important part of this is that this is running Android 4.4.2. It's Samsung SE Linux, Samsung Knox, latest greatest. There are no additional updates to this Galaxy S4 that I'm showing. So I'm just going to start a Hello World example. Hopefully this works. Hello World, you can see. So as you can also see, I'm not a GUI programmer. Just trying my best. So let's see if something happened on this side. So all of a sudden, we can execute commands. So we have a complete shell to that sandbox of the hybrid application.
Yeah, so if you have, for example, one single XSS in your hybrid application, that could be used to inject this and run code.
And of course, we're limited to the sandbox of that application. But I mean, if this is the Android browser, then we have access to almost anything. Cookies, credentials, all of it. And the same goes for cookies, credentials used in the web view in this hybrid app, of course. And of course, all the rest of the sensitive data in the sandbox. So attackers could actually do a lot of stuff, even if they're sandboxed in this environment. So finally, let's see if we can find back to our slides again.
Swipe.
Yeah. This is not my machine. See if you can do it.
Okay.
You have strange settings for that.
Okay.
Or maybe it's me who have strange settings for it.
Yeah. I don't know. All right. So
there it is.
Yeah, I don't think it will work.
Oh, it was there.
It was there?
Yeah, for a short while.
Okay, let's try
There it is.
There it is.
Ta-da! All right, the final part. So to summarize, use FileVault, BitLocker, or something corresponding to that in your environment. Always use TLS. And limit and know your dependencies, both in the development environment and in your production environment. Limit your interfaces as much as possible and test all the interfaces. Don't only test the user interface, test like web service interfaces and make sure that there's nothing strange going on there or lack of validation and things like that. Implement security based on your domain logic. Remember, Sebastian talked about input validation being part of your domain design.
Yeah, most bugs are security bugs in some sense, because you have a domain and you have something you're allowed to do, and then something else happens. So you need to respect your domain and treat it as security bugs.
It makes it a lot easier not only to develop in that kind of environment, it's also easier to review that kind of code.
Yeah.
Because you know exactly where the validation takes place, you know exactly what data that has been validated and what haven't.
Yeah, cleaner code makes it much easier to find vulnerabilities as a code reviewer.
And definitely don't leave your keys under the doormat. Don't have the code signing production keys in your build server. Thank you very much.
Yeah. Thank you. I don't know if